Alpha Houston on space to ground 1 for Don. We're ready for your downlink.
Okay, I'm going to hit play.
I'm Don Pettit. I was fortunate enough to be science officer on Expedition 6 to the International Space Station. And during this expedition, we had several kinds of science that we did. We did programmatic science, which is well-planned and well-thought-out science, comes up from the ground and is orchestrated from the ground. And then we have science of opportunity. And this is science that is done at the discretion of the scientists on board space station. And this is kind of the discovery science. And during our mission, we called our science of opportunity Saturday morning science. The next experiment we're going to see has to deal with Marangoni convection. And I like to call this the invisible spoon of Marangoni. And for this, we take a standard water film and we develop a series of tracer particle patterns in this film. We let all the fluid motion dampen down. So now we have this nice stationary film. So to your eyeball, it looks like there's no fluid motion there at all. And now look what happens as we bring the tip of a soldering iron up to the edge of this film. All of a sudden, you can see this fluid motion start to form, and it goes towards the soldering iron and then it convects away. And what's happening here, the soldering iron is putting a temperature gradient on the water film, and this temperature gradient in turn causes a surface tension gradient, and the surface tension gradient makes an internal tug of war, and it ends up stirring the fluid system around, almost as if an invisible spoon had been stuck in there and it's been stirred around. And this was named after a fellow by the name of Marangoni who discovered it, and that's why I like to call it the invisible spoon of Marangoni. And here you see the same Marangoni convection being driven, except the light from a flashlight is being used as a heat source. So just simply by shining a flashlight on one of these films, there could be enough heating involved from the flashlight to drive the Marangoni convection.
And this was originally how I stumbled across this. I was shining a flashlight on this film and using a magnifying glass to inspect the tracer particles, and lo and behold, the particles started to move when I shined the flashlight on it. And at first I thought it might be something to do with optical pressure, like you see in the little vane spinning around inside of the light bulb, the glass envelope like a light bulb. But then I rapidly determined it wasn't anything to do with the light per se. It was the heat from the light that was causing the motion, and then that made me immediately think of Marangoni convection, and then I tried to solder an iron.
And this brings something to mind that you may be doing an experiment where you're not interested in Marangoni convection, but it's something that you need to understand, because if you want to do, say, a diffusion experiment, and then you turn on the video lights to take pictures of this diffusion experiment, you may be inciting convection in the experiment that you had no intentions of having there in the first place. So you need to understand some of the subtleties of these fluid forces so that you don't instill unwanted artifact into an experiment that you're doing. And something as simple and as naive as shining a flashlight on your system may actually drive unwanted convection.
Here is a new film that I made, and I took my little pocket magnifier and stuck it in front of the flashlight to try to concentrate the beam to a smaller spot, and it actually drives Marangoni convection better this way. This phenomenon is difficult to observe on Earth because gravitational forces, gravitational induced buoyancy convection results in stronger forces than the Marangoni convection. And so it's really tough to see these kinds of phenomena unless you're in a place like on space station where you can reduce gravitational forces down to a bare minimum, and then you can look at these other kinds of phenomena.
And here's another example of Marangoni convection where the flashlight has been directed into the center of the film, just showing that this convection doesn't need to have the edge of a system in order to operate. You can put it in the center of a fluid system, you can still drive the convection.
And surface tension happens to be a function of temperature. And so next to the soldering iron, we have a different surface tension than further away from the soldering iron where it's cool. And since you have fluid connected with different surface tensions, that manifests itself as different forces in different locations on the fluid, and it incites flow.
And something as simple and as naive as shining a flashlight on your system may actually drive unwanted convection.
And Houston Alpha, that's it for our Saturday morning science.